Hello, future engineers, viewers, subscribers, and students. There is another video in statics, particularly on determining centroid and moment of inertia of areas about any axis parallel to the x or the y axis. And this is intended for slow and weak engineering students, hoping that I can elevate their intellectual level slowly but surely. And for those who are interested, just stick and be patient in my videos, because if you really understood the concepts and principles, you will really be transformed into better engineering students. So here is the problem. For the composite and concentric areas shown, compute the following: Ix, Iy, Igx, Igy, I11, I22 if x2 is 2 and x sub 2 is 3 units. So there's no unit, so that this is applicable for all units. Now, for part F, I will leave this to you as your exercise so that um, you can say if you really learn or understood the concept on computing moment of inertias. So here is the guide for a circle. Remember that the moment of inertia of the circle with respect to the diameter or diametral axis or any axis through the center is pi over 4 r to the fourth. Just refer to the derivation for those who are not yet familiar with the moment of inertia of a circle. But even if you're a slow or weak engineering student, you must also look at the derivation of this formula in books and in my previous videos, especially the starting topic section on moment of inertia. So this is the problem at the right. This is the problem. These figures are concentric, so meaning they have the same common center. So the centroid therefore is at the geometric center of the two figures. So here, the dimensions of the rectangle 4 by 6, the diameter of the circle is 2 units, meaning the radius is 1. So for Ix, we simply transfer each formula. You may use the technique I presented before, especially on part 1 for the longer way, but this time I use the shorter way. We transfer immediately the moment inertia of this rectangle with respect to the centroid, then we less the transfer moment inertia of this circle with respect to the centroid to this x-axis here. So for the rectangle with respect to the centroid, 4 6 cubed over 12, then plus area 24, distance of the centroid of rectangle to the x-axis is 6, where 6, by the way, the area is 4 times 6 or 24 for the rectangle. And that's the centroidal moment of inertia of the rectangle, base height cube over 12. Then the distance of the centroid of the rectangle is 3, half of 6 is 3 plus another 3 given. So that's why it's 6 quantity square. Then minus the centroidal moment of inertia of the circle, which is pi over 4 reduced to the fourth, is the guide. And plus the area of, so that's quantity plus the area of the circle, which is pi radius square, pi 1 square, so it's simply pi. Then the distance is the same because the two figures are concentric, so 6 square. Calculating with your calculator, it is 822.12 units to the fourth. Similarly, Iy is equal to, we just interchange the term, the quantity that is cube. So it is 4 cubed times 6 over 12 plus 24 times 4 squared. The distance this time is 4 of the centroid of the rectangle from the y-axis. Half of 4 is 2 plus another 2, so that's why it's 4. Then minus, we transfer the moment of inertia of the circle, which is pi over 4, 1 to the fourth. plus the area, which is, so quantity plus the area, which is pi 1 squared, and the distance of the centroid of the circle from the y-axis is also 4. So that's why we have 4 squared. Calculating, it is equal to 364.95 units to the fourth. Next, we proceed to part C. Since the centroid of the two concentric figures is here, so that's all. We don't need to locate the centroid of the net area, composite areas, because it is readily located here. So we just subtract the centroidal moment of inertia of the circle. So it is, if it is IGX, it is 4 6 cube over 12, this one, then minus pi over 4 1 to the fourth. 4 6 cube over 12 minus pi over 4 times 1 to the fourth. And that is equal to 71.21 units to the fourth. Next, for IGY, you just interchange, the circle remains the same. So 4 cube, 6 over 12 minus pi over 4 1 to the fourth, and that is equal to 31.21 units to the fourth. Then for I11, this is the axis 11, and it is 1 unit from the top. So the centroid of the two composite areas from axis 11 is 2. Remember, half of 6 is 3, then minus 1 is 2. So you may also use transfer formula. IGX plus area, the area is 24 minus pi over 4, minus pi rather. Then the distance is 2 square as an alternate solution. But in this case, I just transfer each the longer way. So it is 4, 6 cube over 12 plus area 24 times 2 squared. Remember, 2 is 3 minus 1. Then minus pi over 4, 1 to the fourth, plus area pi 1 squared. Distance is the same, 2 squared. So I11 is equal to 154.65 units to the fourth. Another way to solve for I11, and I want you to verify this, I just dictate. It is equal to IGX, which is 71.21, plus the area. So the area is the net area, 24 minus pi, quantity 24 minus pi. Then the distance is 2 square. Check if it is equal to this I11. Then for your part, as I said, this is your part. I22 when x2 is 2 should be equal to IY, because if x2 is 2 and the figure is geometrically symmetric with respect to the centroidal y-axis, so the distance of axis 2, 2 and axis YY are equal from the centroidal y-axis of the composite area. So we expect that at moment of inertia at about axis 2, 2 is also equal to IY, which is 364.95. Then with respect to the axis 2, 2, then you may use this idea, transfer its the moment of inertia, centroidal moment of inertia, which to axis 2, 2, and x2 is 3 this time. Or the other way is, if you want to verify, it is IGY, which is 31.21, then plus net area, which is 24 minus pi, and the distance is 2 plus 3, so 5. So 5 square, that's the distance. And show that, or verify that it is equal to 552.67 units to the fourth. So that's it for this video.